Uh, Hello everyone, my name is Rutik Kankired and now I am going to explain about the bridges, types, components, its concept, design concepts and its failures. Uh, let's start. Classification of bridges based on function. There are various classification of bridges on their functions. First is road bridge. Road bridge designed for vehicular traffic, including light and heavy vehicles. Second one is railway bridges. Cater to train load and require special design for dynamic forces. This bridge is designed for railway for heavy loads. Third one is pedestrian bridges, meant for foot traffic. Design prioritize light load and aesthetics. These bridges are for uh, foot traffic and for human use. Uh, Fourth one is pipeline and utility bridges. Carry service like water, gas, and electricity. Bridges are constructed for the carrying services like water, gas, or electricity, etc. Uh, Another classification based on the material. Bridges classified on material based on the different material such as timber, steel, reinforced, prestress, etc. First is timber bridges. Timber is a traditional way which is used in rural and temporary applications, and nowadays the steel bridges are very popular because it's high strength, good for long span but prone to corrosion. This is a side defect of this bridge. Nowadays the reinforced concrete bridges also in use because of its durability and versatile and widely used. Uh, and pre-stressed concrete bridges are used for longer span and reduce the structural depth, which is economical and sustainable. After that, classification of bridges based on the structural form. First one is beam or girder bridges. Simple structure common in short span. These bridges are now commonly used in India because of this simple structure and used for short spans. Second one is arch bridges, transfer load through compression to abutment. Nowadays, this bridge are also popular because the arch due to arch the load passes through compression to abutment. And third one is truss bridge, composed of interconnected triangles, ideal for heavy loads. Fourth one is suspended and cable stayed bridges used for very long span with slender profiles. Suspension or cable stayed bridge are nowadays popular because it used for very long span. Next is components of bridge superstructure. Components of bridge superstructure. First one is deck. Deck is a surface on which traffic moves. The deck means the road on which the vehicles are moved. Second one is girder or beam. Primary load carrying member. Girder or beam is a primary load carrying member which support the deck. Third one is slab. Transfer the vehicle load to girder. The slab which transfer the load of the moving vehicle to the girder, and then girder passes it on abutment. Cross girder and bracings provide lateral stability. Bracings provide the lateral stability to the bridge. Next one is there are mainly two types of components of bridge. First one is substructure and second one is superstructure. The substructure is down of the bearing, the structure which is constructed down of the bearing, or the structure above the bearing is called as superstructure. The substructure are various substructure parts like piers. Piers is a vertical support transferring the load to the foundation. Pier we also know column Column is pier is like a column, but transfer heavy loads, which is used in bridges. Abutment are the end-to-end support of the long span. End support that retain the approach embankment. Third one is wing wall. Wing wall is used to retain the earth at bridge approaches. Pedestal and bearings allow movement and distribute load. Bridge foundation. It is also a part of the substructure. Shallow foundation. There are three types of foundation: shallow foundation, deep foundation, and core protection. Shallow foundation, spread and pad footing used where soil is strong, where the soil bearing capacity is nominally strong, their shallow foundation are used, and deep foundation, piles and well foundation used for poor soil condition, where the soil condition is very poor. There, the pile foundation or the pier foundation is used. The third one is core protection, stone, mats, or concrete to prevent the erosion near foundation. Economical span concept. What is economical span concept? Economical span means the minimum total cost, superstructure plus substructure. The cost of the span is minimum. It's called as economical span. Shorter span need more piers, high substructure cost. Longer span need more girder, higher superstructure cost. Optimization needed for material and labor efficiency. Afflux. What is afflux? Afflux is a rise in upstream water level due to bridge obstruction. The water in the river is increased due to the obstruction of the bridge pier. This rise in level is called as the afflux. Important in flood-prone areas to avoid the upstream flooding. Calculated using the formula like Mollesworth or empirical charts. Various empirical charts are there to calculate the afflux depth. Require provision of adequate waterway area. High flood level (HFL). HFL is a high flood level attained by the river during the maximum flood. It is average of many years. It is the highest level attained by river during the maximum flood. Used to set the deck and foundation level. The deck must above the HFL. Freeboard is added to HFL for safety. Freeboard is a distance provided after the HFL. Some distance are provided, vertical distance, to avoid the submergence of the deck. Determined using the hydrological and historical data by meteorological department. Score depth. Depth to which riverbed may erode around the bridge foundation. Around the bridge foundation, the water in the river may get eroded the uh, surrounded surface, which is harmful for the foundation. Depends on the flow velocity, soil type, and obstruction. It is the score depth is depend. Calculated using the Lassis or IRC's formula. Crucial for safe foundation and depth design. This is important for foundation protection. Loads on bridges. There are two types of load: static load and dynamic load. First one is static load. Static load, there are various loads like dead load, lie load, static pressure, settlement load, and in dynamic or environmental load, impact load, effect of moving vehicle. Impact load is a live load, a type of live load which is directly impact effect of moving vehicle. Wind load, pressure from wind, heavy wind, especially to tall bridges. Seismic earthquake load also induced on the bridges. Temperature load, expansion and contraction due to thermal effect also load on bridge. Now IRC load specification. IRC 6, IRC class A. There are various types of bridges on the IRC classification. First one is IRC class A, normal traffic on all roads. IRC class double A, heavy industrial and defense vehicle. IRC-70R military tanks or equivalent. IRC Class B low traffic rural road. A load combination also specified for design safety. Bridge failure in India overview. There are frequent causes due to scoring of the foundation, overloading, poor maintenance, and etc. Many reasons to failure of the bridges. Construction defect or use of substandard material. Um, Poor quality of material and construction also caused the failure of bridge in India. Hydrological misadjustments. Example, ignoring HFL or APLUX. It is very important to check the HFL or APLUX of the river. Inadequate inspection and retrofitting practices. Bridge failure example in India, Morbi Bridge. In 2020, the Morbi Bridge is a pedestrian bridge collapsed due to faulty maintenance. Uh, Kundli Manesar Palwal KMP Expressway collapsed during construction. Several railway bridges failure due to score and aging. Highlights the need for periodic safety audits. Maintenance and inspection. Routine, periodic and special inspections, monitoring score, crack, corrosion and bearing movement. Using use of technology, drone sensor, non-destructive testing, timely repair, extend life and avoid the costly failure. Maintenance and inspection means periodic inspections, monitoring of scores, etc. Conclusion. Bridges require the multidisciplinary expertise for safe design and longevity. Load consideration, hydrology, and foundation depth are key. Failure often due to avoidable human and technical errors. Sustainable infrastructure demands better planning and regular inspection. Uh, Bridges require the maintenance, periodic or some types of maintenance regularly. The load consideration is very important factor for the to avoid the failure. And okay.